Pick the better search ranker without live traffic experiments. By the end, you will have two simple Python rankers, an offline metric that tells which one wins, and a tiny pipeline that selects the better model automatically. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Real search problems are noisy. Users type short queries. Systems return many near matches and some irrelevant results. Offline A/B testing of rankers helps you compare options without rolling live changes. It answers the basic question of which ranker is likely better before you spend engineering effort. The main trade-off is that offline metrics use labeled queries and may not capture long-term user behavior. Intuitively, we are trying to answer which ranking rule puts the relevant document at the top more often. We start simple with raw term counts. Then we weight rare terms more with inverse document frequency. We evaluate with a clear metric and add a simple filter to reduce off-topic wins. Finally, we pick the ranker with the higher offline score. We will build a tiny corpus, a TF ranker, a TF-IDF ranker, a precision at one evaluator, an all-term filter for TF, and a selector that chooses the offline winner. Now let us build a tiny corpus and a basic term frequency ranker. This snippet creates a tiny corpus and ranks documents by term frequency. It shows how to tokenize queries and documents and count how often each query term appears in each document. The idea is simple and intuitive. A document that contains more of the query terms scores higher. This snippet also makes clear how tokenization, stop words, and case folding change outcomes. If you increase corpus size, the relative differences shrink, and you will see more ties. If you change the ranking scope from whole document to document fields, you will change which documents surface for short queries. Next, we will add document frequency weights, so common words matter less. This snippet adds IDF weights, so rare terms influence the ranking more. In plain language, IDF, or inverse document frequency, reduces the influence of words that appear in many documents and boosts words that are rare and therefore informative. The snippet multiplies term frequency by IDF to produce TF-IDF scores and ranks by that combined weight. Adjusting the IDF smoothing, or minimum document frequency, changes how much emphasis you give to rarity. Stronger IDF will favor niche matches and may help precision at the cost of missing broadly phrased queries. Now we evaluate both rankers offline using a simple metric. This snippet evaluates both rankers offline using precision at 1 for the query. Precision at 1 measures whether the top-ranked document is relevant for a given query and returns 1 if it is and 0 otherwise. Then averages across queries. The snippet runs each query against both rankers and computes this average. It also shows how a small test set can flip a decision, so you learn to inspect per-query failures. If you increase the number of evaluation queries, your offline estimate stabilizes. If you change to precision at 5, you reward a different ranking behavior. Then we tighten the TF ranker with an all-term filter to avoid off-topic matches. This snippet adds an all-term filter to strengthen TF against off-topic matches. The filter requires that every query term appears in a document before that document is considered for ranking. The effect is a stronger precision boost for exact matches and fewer false positives when a popular document contains only one shared word. You can make this softer by requiring a fraction of terms or a minimum match threshold. Raising the required number of matching terms increases precision but reduces recall and may drop partially relevant documents for verbose queries. Finally, we pick the ranker with the higher offline score as the winner. This snippet picks the ranker with the higher offline score as the winner. It compares the precision at 1 values computed earlier and selects the model that scored better on the test queries. The snippet also illustrates a simple tie break and suggests inspecting the per-query differences for diagnostics. Be careful that a small difference might be noise. If you have more evaluation data, you will reduce that noise. You can also add a statistical test or require a minimum margin before declaring production promotion. Recap: what it is: a small pipeline that builds 2 rankers, evaluates them with precision at 1, and chooses the winner. When to use it: when you want a quick, low-cost decision before launching a live experiment. One caveat: offline metrics do not capture long-term user behavior and can be noisy on small test sets. Next step: take this exact pipeline and tune the representation. Try TF-IDF with character and word n-grams to capture partial matches. Measure how n-gram size changes precision at 1. Then scale the corpus and add an approximate nearest neighbor index for faster runtime. Track both accuracy and timing to see real trade-offs. If practical IR experiments help your work, subscribe and watch the rest of the IR videos.